Yeah, I'm super happy to talk about this. It's something I've been wanting to do for a long time, and I'm very happy that it's finally taking shape. Um, I want to do like a high-level thing. Um, what makes Galaxy great? And I think there's as many answers as people in the room. However, I think there's a few values that really go beyond just the particular thing you as a user need, but there's something that connects all of it together. And I think it's always been in the center of Galaxy and also the communication outwards. So um, this is from one of the first Galaxy papers. So there was this strong focus on accessibility, reproducibility, and transparency, and like this is a difference of 14 years, the two papers, and still, I think this is still a good like representation of what Galaxy is about. Yeah, that's it. Very long for no, there's always something to improve and to work on, and I think we've been really good at using what we have to the best of our abilities and adapting to new technical solutions coming in, new requirements. And so where do tools fit into like these different categories? So tools are mostly maintained by communities. I put just a couple here. Of course, there are so many more, but the IUC is a big one. And that's great. Like I have no complaint with that. This is how it should be. Like we can share things. You don't have to reinvent the wheel every time. Reproducibility, I think it's also great. Like the tools, they're not hard coded to a specific environment. At least the community maintained ones. You can, and of course, do it. But generally speaking, the community maintained tools. You can install them on any server, and they are going to work the same way. And we have separated this from the dependencies. So your dependencies can come from different places. They can be containerized. They can be Conda. Other things are possible, but these are the main things. And accessibility. Well, of course, it's great that those tools are available in public instances, but not all the instances have all the tools. And an admin needs to install the tools, right? And admins either read the tools or in most cases just basically trust that the reviewers from the community have done a good job and made sure as these tools are not doing funky things, and that also all the sort of accidental and dangerous patterns have been taken care of. And I think we can do better there. And then there's final thing, transparency. So the tools generate commandments in the end. That's what's going to be executed. And you can look at them, and it's great. And for simple tools, it's fantastic. For complicated tools, it's a little less clear what exactly they're doing just because they're complex. And then Galaxy being 20 years old, started with tools in YAML, went then to XML. And these days, I think people are more familiar with YAML than XML. So there's some cognitive overhead in like when you get started understanding XML. And we use Cheetah, which is the templating language, which I think is a downside. I'll speak about that more. So in brief, why can users not install tools? Because really they should be able to run what they want without having to pass through some gatekeeping process, which effectively is required currently. So you've done your analysis, you're like 70% of the way through, but you need to transform your data in a specific way, and that tool is not there. You are in a position where you can't immediately proceed. And I think that's something that is blocking people from fully embracing Galaxy. And it's a minor thing. You can of course get involved and get the things done, but it takes time, right? And I think Jan was also talking about this. And well, I mean, you can already run code with RStudio in Jupyter, and that's arbitrary user-defined code. So why not do this in general for tools? And especially we can isolate the storage and compute. So you may even bring your own. So if you bring your own storage and your own compute, why can you not run your own code? Like Galaxy should be a platform where you can do anything that you want. And it is in some ways, but you still have to talk with people, which is not necessarily bad, but it slows down a sort of explorative process. Yeah, I mentioned Cheetah. So we do what we call templating. What's that point? Well, in the red box, you see a for loop expressed in Cheetah, and then we basically just put in the path of the data set there. But you got to know a lot there, and this is a very simple example. However, like if you compare parameter values with other things, it's really hard to know what is there. If you have a typo, kind of hard to spot. You need tests to actually run them to be certain. So yeah. And there are other things that are even worse. So in Cheetah, you have access to an entire Python virtual env. So the entire server environment is present. So as an example, you could, and there are ways to mitigate this, but you could import path and write things to it. You could query the database. You could even modify data in the database. So that's why that review process is there. That's why the community trust is important. But really, we shouldn't be doing that. Like, it shouldn't even be possible. Like, right? We don't need to be doing that. And like, if you want to allow people to bring their own tools, I mean, there are more things. So right now, there's no guarantee that a tool is going to be executed containerized, which is important if you want to allow people to run arbitrary code. The file system is not necessarily isolated. If everyone brings their own tools, currently the tools is stored in memory. Like a server like EU, I think, uses like just 10 gigabytes of RAM just to keep all the tools in memory. And that's also not exactly necessary. Bitcoin mining is an issue. There's like you got to specify how much CPU, GPU, memory your tool needs, unless this is like really just a simple text transformation tool. So these are things that would need to be solved if we wanted to do user-defined tools. Yeah, I mentioned like currently we do this through the review process. So I think there has to be a better way. I think there is. We can isolate the templating process so that it doesn't have access to the database. We can try to disk. We can require containers. We can use resource specification directly in the tool. And that's better than the alternative we currently have because it's portable. We have Pulsar, which already allows isolating things nicely, so users don't have access to like read-only versions of everyone else's data. And we can store and retrieve tools from the database. We already have that functionality thanks to John Show. So yeah, I mean, this is kind of the replacement for Cheetah. We provide JSON inputs that correspond to the inputs. And then you can, inside the dollar brackets here, you can build your command line using JavaScript expressions. And this is all typed. So these are the inputs that will be provided for this particular input. And then because this is all properly typed, you can hover over the thing and see what it is. Like this is impossible in Cheetah. And if you have a typo error, okay, we have the documentation as well if you hover over certain things. And certain things like typos, or you're accessing something in a conditional that might not always be in the branch that you are. Like you get type error, and it tells you what's wrong, right? Like in this case, did you mean dot sets? No, actually, I mean this is a typo here. If there's no typo here, typo there. So I mean that's a lot more user friendly, and I'm talking about user defined tools, but these are enhancements to the YAML tool language. It doesn't have to be user defined. You can also just use them like any other XML tool. Yeah. So behind the scenes, what's happening is we have a pedantic model for what the tool looks like, and we have a pedantic model that describes what the inputs look like, or the potential inputs and outputs for a tool look like. And we can transform this into JSON schema, and then with very little additional code, Monaco knows what to do with the JSON schema, so it can render like help and all these other things. And from the input object schema, we can build a TypeScript interface, and that's what drives like this error detection. So it's much harder, or let's say it's harder to write things that don't work. You can of course still do it. Yeah. Mentioned resources. So we've also added language to specify how many CPUs you would need, how many memories, megabytes of memory you would need, GPUs, and I've added work in TPV to isolate user-defined tools to specific destinations, and I mean, it's a sample from the test case, but it really passes on the values that you define for cores to the execution environment. Again, for user-defined tools and for normal tools, so tools can come with like reasonable defaults, like the tool author can set up reasonable defaults, and there's no admin intervention required if you need more than one core, if you need more than 4 gigs of memory, let's say. Yeah, so that's kind of how you do this. There is a, I mean, this is the Monaco editor component mounted in the center here. This is the process of writing the tool. And if you've written an XML tool before, like you know all these things already. Like nothing has to be changed there except it's not XML anymore. And the shell command is the one thing that did actually change, that replaces the command we had before that was written in Cheetah. Yeah. So I mean, here I'm testing out a simple tool that just writes out how many cores are available to a text file, and you got to use the from work there to pick up this file from the working directory. Yeah, I mean, there's no inputs, so I'm removing the inputs here, they're not necessary. Oh yeah, and then again, the requirements I talked about. I'm saying I want 3 cores allocated there. I saved the tool, it appeared in the upper corner here. This is the normal Galaxy tool interface, and then it starts running. We have 5 minutes left. I mean, since I pre-recorded it, the answer wrong window. But this is, I had a local development machine that didn't quite work. Anyway, this is also start running automatically. Click. Okay. You can of course also use them in workflows. So I've already added a few of those user-defined tools. So I'm just going to show how that works. Like these tools are not globally available. Like they are specific to you as a user. We don't want to pollute like the whole Galaxy instance with these custom tools. But yeah, I mean, I've just, this is a user-defined tool. Save it. Find the run button. And then you run it. Very simple. It's not really different from standard tools. And yeah, there's also the new interface that you can see here. just works. And then, yeah, you can download it. And the workflow itself contains the definition of the tools. So if a different user takes the workflow and runs it, it will also import the tools that are part of the workflow. I'm going to skip that because I mean, you don't have to write all these things. You can also just use the link to GitHub or whatever resource where your tool definition is stored. That's what you can see there. This is how you enable it. Anyway, this is in the docs. I'm going to skip this. There are a few limitations because Galaxy tools are a big thing. They have a lot of different features. Some of these things are not implemented yet. The hardest one is there are no macros yet. We'll get there, but that's like one limitation. So what are the next steps? So of course, fix those limitations. Add support to toolshed, Animo, and the Galaxy language server, so you can also have a nice IDE environment outside of Galaxy. I should mention the whole thing can be applied to other things. Like you could have a UI that builds these tools. It doesn't have to be the editor. Perhaps a conversion layer for XML to YAML, so you could like use those new features with existing tools. And then the last thing that is really cool and that I packed together sort of last minute is using an AI to generate the tool. So here I'm doing, I mean, I'm not a front-end developer, just like a browser prompt here. And I'm asking it to generate a tool. What does it do? User specified amount of lines from a file. And I have to add a spinner here. It's now currently talking to the LLM API. And it's comparing it to the Pydantic model that defines the tool. So it will always generate a valid, formally valid tool. The only thing here we have to change is that it specified a container that doesn't exist. So all I have to do is find the proper version that actually exists, save it, and then you have the tool. Like I have a file here with 5 lines, and I'm going to select the first 3. Starts running in Pulsar. I've got 3 lines to go. Yeah, so I think this can improve the overall aims that we have. I think these are slightly more portable, so you don't have to talk to anyone to get those tools in. Again, anyone can bring those tools, so that's quite accessible. And I think that the JavaScript and YAML approach is a little bit more self-documenting, so a bit more transparent. And because these are your own tools, you don't necessarily have to implement each and every single feature flag, as we do with community shared tools. Yeah. So it may or may not come to a server near you in the future, but if you run one, you can be able to try. Yeah, so big thanks to John Chilton, Michael Crusoe, and Nicolas Soranzo, who have also helped me. And John built actually already a good bit of the features needed there years ago, and now is the time to put it together. Yeah, thank you.
Yeah, thanks. Are there any questions?
Yeah, I guess.
Yeah. Thank you, Marius, for inspiring and exactly the kind of gap we try also with the beautiful or strange 2 steps approach. Maybe the major question I have is on the management of the dependencies. Here for now it's only containers who are directly allowed. You can't specify the container speed or something like that for now, but it can be in the architecture and close future. But if any kind of user can ask the download and launch of their own containers. I am thinking about people creating R scripts. I can imagine I can try to create something with help to create the container for that guy. But you can imagine you have a lot of different containers who can be more beautiful, more managed in another way, in a shareable way. If you have, I don't know, if you have 100 users who are each specifying 10 custom tools, you have probably a lot of containers who are used in EU, and maybe you don't have the beautiful manner to rationalize this container who can maybe share same dependencies or things like that. I don't know if it's clear about this.
Yeah, I guess your concern is that there will be too many individual containers. So I think we want to initially limit it to biocontainers, images that are there, and they are generally speaking present. Like we host them on cpmfs on newsgalaxy.org, and putting in a container, like I think the limit is how much can be hosted in biocontainers. What we can pull down from biocontainers, I think, is not so much of an issue. But also, I don't know if this is coming to EU. I know you have some reservations. It will come to .org, I think, and we'll get some hands-on experience. I mean, also like the network is off, so you can't do like live Bitcoin mining. You can play with like how long can these tools run. Yeah, I mean, it's, perhaps the first audience is the one that already runs a server, maybe in the Anvil model or like the isolated model where you are the only user on the server. I think that it makes a lot more sense. And like, as I mentioned, the goal is also that you take these and then you put them in a community when you know they work. Like you've maybe tried it on your large data set, you've tested it already on a live instance, and it like decreases the amount of time to go from like, oh, there's a bug, you want to fix it, and then maybe you push it to the repo, it got published to Toolshed, the admin installed it, and then you realize, well, there's another issue. So I think that's maybe the first thing to aim for. And like you could still define them, but just not be able to run them on. Yeah, it's also an option.
Thank you. Really interesting.
On your examples, we use shell command. Did you think about using interpreters for languages like ARM?
Yeah, so I mean, it mirrors what Galaxy does. So you have a couple of options. So config files are supported. So you could write in your config file an R script, and then your shell command is basically just R script with a path to the script you wrote. Or you can have your script be the input to the tool, right? So the first input is your script input, maybe with a default value for a default script. But then the user can bring a different script. So that's, for instance, something you can do for notebooks. Like you have a notebook runner and the user brings the notebook as an option. I don't know what a more native integration in different languages would look like.
Okay. Are there any other questions?
I mean, come see me. I can also give you more detailed demo. I think I'm going to over time. There's a
Just ask.
I'm sorry, first.